In the present lecture, we will discuss the example problem on a two-phase simplex method. Let's see the problem. Uses two-phase simplex method to solve maximize z equal to 5x1 plus 3x2 subject to 2x1 plus x2 less than or equal to 1, x1 plus 4x2 greater than or equal to 6, x1 comma x2 greater than or equal to the 0. Let's see the solution. First, we have to convert the general linear programming problem into standard linear programming problem. For this, we have to introduce the slack variable and surplus variables and artificial variables in the constraint. First constraint is having the less than or equal to inequality symbol. So we have to introduce the only slack variable, that is S1 slack variable in the first constraint. Second constraint having the greater than or equal to inequality symbol. So we have to introduce the surplus variable, let us consider S2, and also have to introduce the artificial variable A1. Then constraints will become 2x1 plus x2 plus s1 equal to the 1, x1 plus 4x2 minus s2 plus a1 equal to 6, and x1, x2, s1, s2, a1 are greater than or equal to the 0. Next, to find the initial basic feasible solution. For this, we have to consider the all the basic variables and the surplus variables are 0. Here basic variables are the x1 and x2 and the surplus variable is the s2. So let us consider x1, x2 and s2 are the 0 and substitute these values in the constraint equation. Then we will get the s1 value is the 1 and a1 value is the 6. So next we have to go for the phase 1. Phase 1 is for the eliminate the artificial variables. So first we have to assign a cost value is the -1 to each artificial variables and cost value is the 0 to the other variables. Then the new objective will become maximum z equal to 0x1 plus 0x2 plus 0s1 plus 0s2 minus a1. And constraints will become the same only, it will be not changes. So constraints are the 2x1 plus x2 plus s1 equal to 1, x1 plus 4x2 minus s2 plus a1 equal to 6. Next we have to construct the initial simplex table. So this is the initial simplex table. Here B is the basic variables. So initially our basic variables are the S1 and A1. CB is the cost coefficients. For the S1, cost coefficient is the 0 and for the A1, cost coefficient is the -1. So introduce here in this table. So basic variables are the S1 and A1. CB values are the cost coefficient values. For S1 0, for A1 -1. XP is the basic feasible solution. So this is the initial simplex table. So initial basic feasible solution is the S1 equal to the 1 and A1 equal to the 6. And CJ is the cost coefficients for the basic variables and surplus slack variables and also for the artificial variables. For this one I have to observe the new objective function. So here observe the cost coefficient values. For x1 it is the 0, for x2 it is the 0, for s1 0, for s2 0 and for the a1 -1. Next to write down the coefficients of the variables by observing the constraint equation. In the first constraints, x1 coefficient is the 2, and x2 coefficient is the 1, s1 coefficient is the 1 and x2 coefficient is the 0 and a1 coefficient is the 0. And similarly, by observing the second constraint equation, here coefficients of the x1 is the 1, coefficient of the x2 is the 4, and here for the s1, here there is no s1, so its coefficient is the 0. For the s2 it is the -1, and for the a1 it is the 1. So next we have to determine the Zj minus Cj values to check the basic feasible solution for the optimality. So Zj minus Cj is the summation of, so multiplication of Cbj into Xj minus of Cj. So first we have to determine the Z1 minus C1 for the first coefficient, that is for the x1. So for the x1, so Zj minus Cj value is the 0 into 2 plus minus 1 into 1 minus of 0, that is the -1. Similarly for the second variable for x2, Z2 minus C2 value is the 0 into 1 plus minus 1 into 4 minus of 0, its value is the -4. Next Z3 minus C3 for the third variable, that is for the S1, so that is the 0 into 1 plus minus 1 into 0 minus of 0, its value is the 0. Next Z4 minus C4 for the fourth variable, that is for the S2, 0 into 0 plus minus 1 into -1 minus of 0, its value is the 1. Next Z5 minus C5 for the fifth variable, that is for the A1 variable, 0 into 0 plus minus 1 into 1 minus of -1, its value is the 0. So here Zj minus Cj values are the -1, -4, 0, 1 and the 0. If all the Zj minus Cj values are the positive mean, we got the optimal solution. Otherwise, we have to select the most negative value. So most negative value is here -4 for the x2 variable. So x2 column we are calling as the key column, and also it is calling as the incoming vector. And here x2 variable is entered into the basis. Initially in the basis there is a no x2. Next we have to replace the x2 in the basis. Next we have to determine the minimum ratio of the xb divided by coefficient of incoming variables. So first I have to look for the first row. For the S1 row, xb value is the 1 and coefficient of the incoming variable is the 1. So 1 by 1 equal to the 1. So next we have to look for the second row, that is for the A1 row. xb value is the 6 and its coefficient value is the 4. So 6 by 4 equal to the 1.5. So here you have to select the minimum ratio. Among 1 and 1.5, minimum ratio is the 1. So minimum ratio is 1 and indicated by arrow, and S1 is the outgoing vector, which means S1 is the leaves the basis. So next we have to look for the identify the common element in the key row as well as the key column. So here key row is the S1 row, key column is the X2 column. So for the S1 row and X2 column, common element is the 1. So 1 is we are calling as the key element. So next we have to construct the new simplex table by entering this incoming variable. Next to construct the new simplex table with the reference of the old simplex table. Here Z2 minus C2 is the minus 4 is the most negative value under the X2 column, and we are replacing the slack variable, that is the outgoing variable S1 with the incoming variable X2 in the basis. So we have to replace in the new simplex table. So write down the X2 in the basis and also write down the CB value is the 0 because its cost coefficient is the 0. So next applying the following row operations to get an improved solution. First row operation is the R1 new equal to R1 volt divided by key element. Here key element is the 1. So R1 new will become the R1 volt divided by 1. So we will get the same values. So first row values are the same as it is in the old simplex table. That is the 1, 2, 1, 1, 0 and 0. So next operation is the R2 new equal to R2 volt minus 4R1 new. So first write down the R2 volt elements. R2 volt elements are the 6, 1, 4, 0, minus 1 and the 1. Next write down the R1 new elements, that are the 1, 2, 1, 1, 0 and the 0. So next we have to do the operation 4R1 new. So multiply with the 4 for all the elements, then the 4R1 new will become the 4. So 2 into 4 8, 1 into 4 4, 1 into 4 4. So 0 into 4 0, 0 into 4. Next we have to do the operation R2 volt minus 4R1 new. So R2 volt 6 minus 4 is the 2, 1 minus 8 minus 7, 4 minus 4 0, 0 minus 4 minus 4, minus 1 minus 0 minus 1, 1 minus 0 1. So these are the R2 new elements. So next once again I have to calculate the Zj minus Cj values and I have to check the basic feasible solution for the optimality. So first we have to do the Z1 minus C1. So Z1 minus C1 is the 0 into 2 plus minus 1 into minus 7 minus of 0. It is the 7. Next Z2 minus C2 is the 0 into 1 plus minus 1 into 0 minus of 0. Its value is the 0. Next 0 into 1 plus minus 1 into minus 4 minus of 0. It is the 4. Next 0 into 0 plus minus 1 into minus 1 minus of 0. It is the 1. Next 0 into 0 plus minus 1 into 1 minus of minus 1. Its value is the 0. So Zj minus Cj values are the 7, 0, 4, 1, 0. Here all the Zj minus Cj values are the positive values. And also check the other condition. So have to verify we got the optimal solution or not. So here all the Zj minus Cj values are the positive values. And one more thing you have to check, maximum Z star is less than the 0 or the equal to 0. So maximum Z star is the product of CB into XB. So that is the 0 into 1 plus minus 1 into 2. It is the minus 2. So here, so in the Zj minus Cj values, if it is all the get the positive values, then once again have to check the other conditions. That is the first condition is maximum Z star is equal to 0 or less than 0. Here we got the less than 0, that is the minus 2 value. And one more thing you have to observe. So in the basis, at least one artificial variable appear or not. So in the basis, we got the one artificial variables. So we got the all the Zj minus Cj values are the positive. After getting the positive values, we have to check the another conditions. That is the maximum Z star is equal to 0 or less than the 0, or any artificial variable is appear in the basis. Here all Zj minus Cj values are the positive values, but Z star value is the less than the 0 and artificial variable is appear in the basis at the positive level. So it is the positive level. So in this condition, we will be not get the any feasible solution. So for the given problem, we will not get the any feasible solution by applying the two-phase simplex method. So this is the solution. So these type of the conditions, we will not get the any feasible solution. Thank you.